Yeah, okay.
Yeah.
Okay. Let's wait for a couple of more minutes for other people to join, and then we'll start. Yep. Let's start our today's discussion. Today we are going to discuss about Spark data frames, data frame API. Till now we have seen RDD API. Wherein we used to work with transformations and actions, right? We have seen broadcast variables. We have seen accumulators, right? So we have seen examples for RDDs, how to create RDDs from the collections, how to create RDDs from the text file. So everything we have seen. Today we will be moving into data frames API. So which is very important topic in PySpark. Okay. So before going to that, let me quickly recap what we have discussed in our last session. Let me start sharing my screen. Are you able to see my screen?
Yeah.
Yeah. Okay. So I'm just opening my cluster in my notebook. Oh my god, this is becoming a problem. Okay. So I think it is again giving the same problem. Let me delete and create it. Okay, let it create in the background. So yesterday we have discussed about broadcast variables and accumulators. Okay, so broadcast variables and accumulators. So these are the shared variables, we'll call them as. So these variables can improve the performance of your Spark application, because instead of creating a normal Python variable, if you can create these broadcast variables or accumulators, so these variables can improve the performance. So broadcast variables are for reading, accumulators are for writing. So this is the core purpose of these two variables. Okay. Yesterday we have seen application deployment as well. So when it comes to application deployment, so we have discussed about how to deploy a application. So here, if you see, I have a Python code or else PySpark code here in my Python file. Okay. So the first and foremost step is to import whatever required. Okay. And I'm creating a Spark context. I'm creating a Spark context, and then I have a file or data that is available in my GCS path. Okay, and then I am reading that GCS path and creating the RTD, and I'm using the flat map on top of the RTD, and then I'm splitting it. So the responsibility of this Python or PySpark program is there is a text file in my GCS, so it has to read the text file and count how many times each word got repeated in the text file. So that is the logic that we are doing. So we call it as a word count program. Okay, so we used flat map first, and then we have splitted the line, each line with space, and then we used map transformation. For each word we allocated a value called 1. Okay, and then we used reduce by key transformation. So for the same key it will sum up all the ones. So we finally achieved our word count logic by using the RTDs. Okay, by using the RTDs. So when if we want to deploy this application, so we will use a command called gcloud dataproc job submit. So here, if you see, this is the command that we will use, or this is a statement that we'll run to submit our Python file or PySpark file to the cluster. Okay, so gcloud dataproc jobs submit PySpark. So this is something that you need to pass as a default statement, and then your Python file. Okay, and then your cluster name hyphen cluster equals to jobs hyphen cluster, and then your region hyphen region equals to west one. So by triggering this command, so you can submit your job to your Dataproc cluster. Okay, so that is something that we have discussed about application submission yesterday. Okay, or day before yesterday. So this is very important in real time. So in real time, we should not be using shell based environment. So we will use shell based or notebook based environment for developer testing. Okay, but when it comes to the real time deployments, so we use the application level deployment. Okay, so we use the application level deployment. Okay, so that is something that we need to understand before entering into. So this is okay. Looks like it is. Okay, fine. Let it leave it. So let it open slowly, or else. Meanwhile, what I will do, I will just try to delete it. Oh, cancel. Okay, looks like there is some issue with. Okay, fine. So that is what we have discussed yesterday. So today we will be moving into data frames, Spark data frames. Okay. So data frame is also abstraction for processing the structured data in Spark. Okay. So when it comes to data frames, it is very important to know about data frames when you are working with structured data in Spark. Be very clear. Okay, so today we will see the internals of data frames, and we will understand how to create data frames in Spark. Okay, so this is one more abstraction, guys. This is not a rocket science as such. Okay, this is one more abstraction on top of your RDDs. Be very, very clear. Okay, now if you don't have structured data, or if you don't have metadata, or if you don't have a schema for your data, or if you don't have attribute names for your data, then what you do, you go for RDDs. Okay, but if you have a file with a structured content, meaning a table like structure, or a parquet file, or a JSON file, or a CSV file, right? So if you have structured data formatted files, then the recommendation is to use Spark Data Frame API. Be very, very clear. Okay, so the Spark Data Frame API is more optimized compared to your RDD API. Be very, very clear. Okay, so Spark Data Frames API is more optimized version of your PySpark. Okay, so these data frames are very important in real time, real world projects, because majority of the times we will be getting structured data. If not structured data also, you can use this data frames. Okay, you can use this data frames by converting your RDDs to data frames. Okay, once you have a unstructured log file, you read it into RDD, and then you clean it, get in, get proper columns from that RDD, and then assign schema for that RDD, create the data frame from it, and then write it into a structured format. So that's how we use in few cases. Okay, so the features, right? So the features are integrated, unified data access, and then high compatibility, standard connectivity, scalability. So whatever the properties that you have in RDDs, the same properties will follow to the data frames as well. Okay, remember these data frames can read data from different source systems. Okay, different source systems. One more powerful thing in data frames is you can directly connect to a RDBMS source and read the data. So read the table data. That is spark.read.jdbc. That is the default reader that we have for reading RDBMS based data sets. Okay. Similarly, for Parquet, we have Parquet reader. For CSV, we have CSV reader. For XML, we have XML reader. For Avro, we have Avro reader. ORC, we have ORC reader. So for all the different file formats, we have unified data access. So it means the central API, we can call it as in PySpark. So there is no data set in Python PySpark. Okay, so PySpark doesn't support data set. Data set is the more advanced version of your data frames. Okay, but PySpark data set and data frame both are same. Okay, but if it is a Scala Spark or Java Spark, data set is the latest API that we need to use. Okay, fine. So features of a data frame. So the data processing from kilobytes to petabytes it can handle, and it has default data formats: Avro, CSV, Elasticsearch, and then Cassandra. So you can read the data from multiple different sources. And then state of optimization and code generation through the Spark SQL Catalyst Optimizer. This is the very important thing in data frames. Okay, Catalyst Optimizer. So this service or this utility will come by default in data frame API. But in RDDs, you don't have this Catalyst Optimizer. Be very, very clear. Okay, so if you don't have this Catalyst Optimizer, what will happen? Your Spark doesn't have the self intelligence to optimize your logical plan. Be very, very clear. You have written transformations, multiple different transformations on the source RDD. Okay, now when you deploy it to the Spark, if it is a Spark core based application, that means RDDs based application, it won't apply any internal optimizations. It won't apply any kind of optimizations internally to your code. Okay. But if it is a data frame based code, or if it is a Spark SQL based code, then what will happen, you will have a catalyst optimizer service internally allocated, and then that service read your logical plan on your data frame based transformations, and then it will optimize your transformations. If any chance is there, if any scope is there for optimizations, your catalyst optimizer will optimize your transformations, and then it will generate optimized logical plan. Remember, it will read a raw logical plan from the Spark engine, and then it will optimize that logical plan and generate the optimized logical plan. So that is the responsibility of your catalyst optimizer. So how it will do, it will have a cost based and rule based engines or rule based plans. It will generate cost based rule based plans in the background for your transformations, and it will pick the best plan for your transformations. So catalyst optimizer is very very important, and it is needed. It will come by default in your data frame based API. Okay. So you can create data frame from files. You can create data frame from RDDs. You can create data frame from Python collections. Okay. You can create data frame from tables that are stored in the external systems like Oracle, SQL Server, Hive, right? So this is very much flexible, guys. This is very simple to for the data processing, to use data frames. Okay. So let us jump into how we can create the data frame from a JSON file, for example, right? So here, if you see data frame equals to SQL context dot read dot JSON, right? So this is in older versions, guys, but in latest versions, your SQL context and your Spark context, all the context objects are part of your Spark session. Be very very clear. So that is why in creation of your data frames, we use Spark session. Okay. So first we create the Spark session, and then we use the readers, default readers, spark dot read dot JSON of your file JSON. Okay. Internally, what will happen, again the same funda, guys. So file dot JSON will be having some content. Okay. Depending on the size, okay, partition size, it will chunk your raw file into logical partitions internally, and those partitions will be sent to executors for execution, and the execution will be done in the executors in the form of tasks. Okay. In the form of tasks, each task will be run on top of one partition, and one partition will be assigned to one core. Be very very clear. Okay. So your jobs, I mean, a day in our previous session, we have seen how to look at the DAG, right? So how to look at the transformations, how to look at the DAG jobs. We have seen actions, right? Stages, and also we have seen tasks, everything, right? So we need to understand that particular thing first. So before going to that, let me create the new cluster. So job cluster -1. Okay. So data frames are optimized, and it has a catalyst optimizer, and data frames can be used for structured data, and it has default data sources. Okay. So in interviews, you may face a question like, what is the difference between RDDs and data frames? This is a very important question in your interviews. Okay. So you should be in a position to answer, and you should point out all these differences. Okay. So that's about the data frames, guys. So how we create the data frames. So here we will see a simple examples. Okay. So Spark session we created, and then we are using that Spark session. Under that Spark session object, we have direct readers. We don't need to go for Spark context at this time. We have direct readers called spark.read.json and the path to your JSON file. Okay. And similarly, the CSV, you can read a CSV file spark.read.csv, and you can pass your CSV file path. Okay. Now your data frame is the logical table. Be very, very clear. So it will become a table, guys, instead of RDDs. Okay. So you can see a table like structure. Okay. So if you want to see what is there in the data frame, you can actually use data frame dot show method to see what is there in the data frame. Similarly, the parquet file. So if you want to read a parquet file, you can use spark.read.parquet. So it will directly create your data frame object. Okay. And converting your RDDs to data frames. This is very, very important when we have existing RDDs. Okay. And then if we want to convert them to data frames, we have a method called 2df. See here, this is my RDD. Okay, this is my RDD spark.spark context.parallelize of my data elements. Okay, and then if you see RDD.to data frame, and then I'm passing my columns names here. Okay, so there is one more way also to create data frames from your RDDs. Okay, so here if you see, I'm just creating the Spark session, and then I'm creating my RDD, and I'm creating my schema for my RDD. Okay, so here if you see, I'm explicitly defining my schema. Okay, and here you don't need to define your schema. Your Spark will take the schema of your columns depending on the data. Okay, but here you can explicitly create schema, and you can use a method called create data frame method under the Spark session, and you can pass your source RDD and the schema to this create data frame method. So your data frame will get created. Okay, so this is how we will create your data frames from RDDs and different file formats. Okay, let's see that practically, and then we'll get more understanding on it. Let's wait for this cluster creation. Okay, meanwhile, we will try to understand the application that we're going to deploy. So we're going to deploy this word count.py, which has a word count logic. And let us quickly understand that logic. So here, if we see, we have word count text file. Okay, this is my text file. Okay, now I want to count how many times each word got repeated, or how many occurrences each word have from this text file. Okay, that is my simple transformation that I want to apply. So if I want to do that in normal Python, understand how many iterations you need to do. Okay, understand how many iterations you need to do, and how many lines of code you will write in Python or Java. Okay, but in Spark, it's a single line program. It's a single line program because of your RDD inbuilt transformations. Because of your RDD inbuilt transformations. So how we have written that logic, we have already seen that, right? So here, if you see, you are reading that word count text file, and you are using the flat map. Okay, transformation, because you need a single data structure to hold all the words. And then once you have all the words, you are using map transformation, because for every word you need to generate a map element, so one-to-one mapping. So that is where you have your word, and then word comma 1. So that means you are assigning a value called 1 for your word, each word, and then you are using your reduce by key transformation, so which will group all the words and then count it or else sum it, right? So that's your logic. Now your cluster got created. Let's deploy this application using our gcloud command that we already have, right? So here, if you see, this is the command that we will use to submit our job. And remember, we are submitting it from your Vertex AI notebook, not from your Dataproc cluster notebook. Okay, you are submitting your job from your Vertex AI notebook to your Dataproc, not from your Dataproc cluster itself. Dataproc cluster can be utilized only for the shell-based practice, not for the job submission. Be very, very clear. Your job submission will always happen from the outside of your Dataproc service. It may be happen from Vertex AI notebook, or it may be happen from Cloud Composer. It may be happen from workflow, right? Because we schedule these jobs, right? So the job will get triggered from there. So you don't run your jobs directly in your Dataproc cluster. So external services will submit your job to your Dataproc. Okay, so now I'm submitting my job from my Vertex AI notebook. Okay, so here if you see G Cloud Dataproc jobs submit. Okay, so this cluster is not found. So we have changed our cluster name. Okay, so here we have submitted our cluster, and then let's go and monitor our job in Yarn portal, or else you can simply go to jobs. Excuse me. Yeah, so you can monitor your submitted jobs from the Yarn or your jobs page. So here if you see one job is started. Okay, and then simply you can go for Yarn also. So here in the applications you can see one application is running. Okay, this is your application and the name is word count, if you see, and you can go and check your it got succeeded, and go and verify your result here. See here each and every word and its count, each and every word and its count. So if you want to write it, if you want to write, you can always use our action, right? So save as text file. So we have this action, right? So you can always use it. You can write it into GC as we write test. Okay, so I'm just writing it into GCS location using the save as text file method. Okay, so that is the action that I'm triggering, and then I'm just saving this file, and then I'm trying to resubmit it. Okay, so now in the Yarn, right? So you can always check the application DAG that got created for your application, and you can pretty well understand how Spark is processing it. Okay, so as yesterday we have discussed about this DAG, right? So in each and every DAG there will be number of jobs. Okay, number of jobs refers to number of actions that you are performing in your code. Okay, under each job you will be having multiple stages. Okay, you will be having multiple stages. Okay, your transformations are responsible for these stages. If you are using wide transformations, meaning transformations which trigger shuffle, those transformations will create new stages. Be very, very clear. Here you used reduce by key. Reduce by key is also a wide transformation. So that is why it has triggered a new stage. Okay. When you use shuffle based transformations, your stages will get created. Okay, the new stages will get created. And similarly, under each stage, you will be having tasks. This is what your DAG consists of, guys. It's a physical execution plan, right? So under each application that you submitted, you will be having a number of jobs created. Okay, under each job you will be having number of stages will get created. Under each stage you will be having multiple tasks to execute. Okay, and each task will be performed on top of a partition, and each partition will be processed by a core in the executor. So we have executor cores, CPU cores, right? So each partition will be sent to each core in the executor, and each partition will be performed by a task. Okay, so that is how the internal architecture of your Spark execution will happen. And you can pretty well go and execute your DAG visualization. See here, text file, and then map partitions. So all your each stage you can visualize your DAG. Okay, so this is a very detailed Spark debugging UI. Okay, you can pretty well debug your application from here. Okay, and you can see for each task what are the logs that you got. Okay, and you can see all the executors also from this page, how many executors that got created for this application, and how many tasks that got assigned, and which executor has performed which task, and what is the driver. And then see here executor ID, and then how many tasks each executor perform, and you can see executor logs here, right? So this UI is the day in day out portal for you guys for all your Spark applications. Okay, be very very clear. See, it got failed, our job got failed. So let us see what is the reason. Interrupted, and then
In syntax, text file, I think that spelling is wrong.
oh, the spelling is wrong. Okay, okay, fine, no problem. Let's go on correct text file. I'm just saving it. I'm resubmitting it. Okay, so this is how your here also you can see all your job logs, guys. Once you click on your job ID, okay, you can pretty well see all your logs here that will print, your application logs here. See here, right? So you have two ways. One, you can go for yarn, and then one you can see the logs from here also. But remember, from here you won't be able to access your Spark portal, but from yarn it will be easy to access your application master portal. Okay, so that is one thing. So now in your data proc, there is a concept called auto scaling. So we'll see that also, and we'll try to understand how this auto scaling will work. But remember, we won't be able to practically show this auto scaling in our free version, because we don't it won't allow us to scale the system that much. Okay, because we are already using the maximum thing, right? Or else we will try to see if we can increase our cluster size automatically by three worker nodes. Okay, so it's just scaling your cluster to multiple nodes. So I'll explain that concept also after the data frames completion. So we'll be almost done with Spark and data proc service. But you need to understand and practice your transformations, everything. Okay, so let's see what happened to our application. Yeah, it is completed. Okay, and then let's go back to our directory where we have. So here, if you see, test word count. So I'm going to my cloud storage. we write test. So we write then test. Then word count out. Remember, you cannot control your file name, guys. Be very, very clear. You cannot control your file names in Spark. Okay. Your Spark always writes the data in its own part file format. Okay. So you can control only the directory name, but you cannot control the file names. Be very, very clear, because these are distributed chunks in nature, and these file names are written by your executors. Okay, so these file names are written by your executors. So these files are already distributed in the cluster, and each chunk is with each, each executor, right? So that is the reason you won't be able to control your file names. So your Spark, by default, it will assign a sequence number called part underscore 000, part underscore 0001. Like that it will assign, and then it will generate the files. Be very, very clear. Okay, so you don't have any control over these part, over these file names. You have the control in the name of your directory only. Okay, that's why we create the table name directory, and then we will insert all the data in the form of Parquet files in the directory. That's it. Okay, so that is how we will write the application and then deploy it. Okay, now let's quickly see few examples of our data frame, and then we will try to wrap up today's session, and we will try to find out a few sources. Test underscore NiFi. Do we have any Parquet file? Okay, we have the CSV file, so let's try to read that. Okay, what is there in this? Okay, this is a Avro file. I'll try to read the CSV file first. So let's see if we have any sample CSV files. So we have one Parquet file. And this is, okay, this is Avro type, but we have the test knife CSV. Okay, so here, okay. So let's quickly read this directory into our Spark. Okay, I'm opening my PySpark. Oh my God. Okay, so I'm just trying to open my PySpark shell, and then let's quickly create the data frame. Okay, so here if you see df equals to spark dot read dot format. This is one more syntax that you can follow. Okay, CSV. Okay, dot option. Okay, so you can pass options also. Header, so that means my CSV file have header. I'm telling my Spark data frame that, hey, in my first line I have header. Okay, so that it can take the column names. Okay, and here you can also pass one more option infer schema. Okay, in first schema you can say true. That means automatically take the schema. Okay, then you can use the load statement. Okay, so I'm just using the load statement and pasting my file path. Okay, this is how you'll specify your GCS path, and then in this directory you can give wildcard also in the path. Okay, star.csv. That means all the CSV files that are there in this directory, read them into the data frame. Okay, I don't know why it is not working. Okay, so we'll do one thing. So we'll try to submit it from our application only. So let's see. So just renaming it data frame underscore example dot py. Okay, so I'm just pasting this line, and before that I need my Spark session, right? So I will try to create the Spark session object. Let's try to create the Spark session object. Okay, so I'm just trying to say data frame example. Okay, and then I'm trying to create my Spark session, and then I'm trying to read the CSV file that is there in the GCS, and then I'm creating the data frame out of it. So here you can pass the show 10 comma false. Okay, this false is basically if you have very huge sized columns, so it will truncate your column data, and then it will show dot 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 dot. Okay, so to avoid that, we will always use false. Okay, so that it will show the complete content in your column. Okay, now let's quickly submit it. So this time we need to pass another py file. Okay, I'm just submitting it to my cluster. For some reason my this notebook shell is not working, guys, so we can use this shell also, I guess. So let me paste this. Okay, control C. PySpark. Okay, so I've just submitted it. We can see the application also from the yarn or wherever we need. Okay, so here if you see, you have two applications that are running in, and then one data frame example also got finished. See here, see your data frame, how it is representing your data, right? So this is how your data frame creation will happen, and the representation of your data frame will happen. Okay, and similarly, yes, here you can also use this PySpark shell, because I don't know, there is some problem with this PySpark notebook. Okay, so it was not opening. Okay, so that is the reason I'm using this. Okay, so here you can pretty well copy paste this line, because your Spark and SC will be by default will gets created in the shell based environment. See here, Spark and context is available as SC, Spark session is available as Spark. Okay, so your data frame got created, so you can quickly use data frame dot show. Okay, see here, you're properly able to see the data frame, right? So your data frame is like a logical table, as I said. So you can use all your statements, guys. So in Spark SQL, all your SQL, that type of things that you are doing, right? So you can always perform those operations. You can always perform those operations, but you need to know how actually Spark works. Okay, so for that you need to understand the Spark native SQL. Okay, so if you want to write SQL on top of this data frames, you need to understand the Spark native SQL, Spark data frames dot filter, data frames dot select, data frames dot with column, data frames dot join. All these are different transformations that you can do on top of the data frames. Okay, when otherwise case when statements you can do. Okay, Venkat, I don't want to perform native SQL. I want to perform normal SQL. Okay, so in that case also it is possible. You can directly pass your SQL query to your Spark Spark dot SQL, okay, Spark SQL engine, and it will understand and it will run the query. Okay, so that is also possible. We'll see all of them in our coming session. Okay, but for now, try to understand how to create the RTD from multiple different file formats. Okay, so I request you to go and create your data frames from JSON Parquet files. Okay, and CSV we have seen, right? So you try with the JSON, you try with the Parquet. Okay, so I am giving one a task to you guys today. So one use case, which is actually on RDDs. Okay, so which is actually on RDDs. So before going to that, let me try to explain one more concept, okay, which is needed for the task. So here, if you see, now we have seen how to create a data frame from a CSV file, right? So similarly, let's see how we can create a data frame from the RDDs. Okay, similarly, let's see how we can create a data frame from the RDDs. See here, I have my data like this. Okay, so I have my data like this. Okay, I'm creating a RDD from my data. I'm creating RDD from my data. Okay, my RDD got created. My RDD got created. And the next step is I'm trying to convert my RDD to a data frame. I'm trying to convert my RDD to a data frame. Okay, so okay, so there is some issue with this cluster, guys. So it was failing, but let's see one more way of doing things. Okay, so I'll try to create the schema. Before going to that, I will try to import this. So these are free version clusters, right? So we face this kind of delays and I know some issues, normal issues, guys. But in the enterprise level Dataproc services, you don't feel these kind of issues. Okay, so I have created the schema also. So now what I'm doing, I'm trying to create my RTD. I'm trying to create my data frame from the RTD. Okay, now my data frame got created. Let me see what is there. Oh. There is something wrong with this notebook. It's okay, guys. So let's let me try to submit it. Let's see whether it will work or not. Okay. Okay, so I just submitted it to the cluster. It is running. The application is running. So here you can see all the resources, guys. So how many total resources you have, right? You have 12 GB RAM and you have 4 cores across the cluster. Okay. And you have used 4 cores on 12 GB. So I mean used resources also it is showing, right? So that is something that I mean you can understand from here how many containers that are running in. I mean how many executors that are running in, right? So that way you can actually debug your applications, how many applications are running, how many applications are in pending state, right? So okay, so it got killed. Agent reports job failure logs. Soon we found that there's some issue with this cluster itself, guys. Okay. Okay, so maybe it is because of this resource constraints, because it is completely used, right? So let me go and kill this Spark session from here. Okay, Control T. Okay, I just tried to kill this Spark shell. Finished. Okay, now let me submit it. So you can kill the application in many ways, guys. So you can use yarn command also to kill your forcibly, kill your application, to kill your application. Oh my God. So, okay. So here you can say yarn application hyphen kill. I can use this application ID so that it will kill the application. Okay. Forcibly it will try to kill it. Yeah, it got finished. Our data frame example got finished and we can see the data. Okay, so if you see, this is how we can convert your RDDs to data frames. Okay, you can convert your RDDs to your data frames by using the create data frame method. Okay, so now please note down the task for tomorrow, guys. Okay, so let me give my sample data. Okay, so here this is my sample data. Okay, so dollar um, testing underscore log. Okay, so this is my begin underscore testing. Okay, let me keep the caps. Begin underscore testing underscore log. Okay, so this is my starting line. For every text file that I'm going to receive, I will be having this structure. Okay, end underscore testing underscore log. Okay, now inside this section I have another section called dollar underscore begin underscore test underscore attributes. Okay, and similarly I have end for this end test underscore attributes. Okay, so under this test attributes I have few columns called test underscore id. Okay, and then I have some wx 00012. Okay, and then similarly machine underscore id. Okay, and then here I have machine id, so which is actually aq0009012. Okay, and then similarly I have machine model. That means where actually the testing is happening, that machine model. So this model is, let us say, md01. Okay, And then these are the uh, okay, test attributes. Okay, similarly I have one more section called test elements. Okay, so I have test elements. Okay, this is my test elements section. And then after the test attribute section, this will start. Okay, now in the test elements section, you have a lot of elements that are there. Okay, lot of elements that uh, you know uh, so the data refers to a testing data. Okay, in a machine you are keeping your manufacturing elements, and then you're testing those elements. Okay, now in one machine you can place multiple elements, right? So for multiple elements you will be having test results that will coming in, whether it's a pass or fail. Correct. So these are the root level attributes, meaning for every test that is going to performed by that machine, it will be having ID. And in a machine we'll do the testing, right? So similarly we'll be having machine ID and the machine model. Okay, and in the test elements section, so you'll be having lines starting with a star. Okay, you'll be having lines starting with star, and each line represents to each element. Okay, so here in the first line you'll be having ID, so 001, and then you'll be having elements. Okay, so elements meaning, so for example, let us say 1 2 3 4 5 6 7. Okay, and in this element you are performing 7 tests. Okay, you're performing 7 tests, and then you're done, and then that's it. So similarly you will be having another element, element 2. Okay, and in this element you will be performing 3 tests. Okay, and then similarly you will be having element 3. For this element you will be performing only 2 tests, and then similarly for element 4. Okay, so this is your data, guys. You need to understand this data very much, so otherwise you won't be able to look at the program. Okay, so now see here, this is structure of your text file, guys. This is your structure of your text file. So like this, you will be receiving your text files on a regular fashion. Okay, on a regular fashion. So from the machines, the log will be generating in this format. Okay, the log will be generating in this format. You'll be having in test log section, and then test log section. Under that section, you'll be having test attributes section and test elements section. Okay, so what you need to do, you need to prepare your data. Okay, so let me save this file. Okay, the attributes and prepare the data frame and write it into the Parquet file. This is the use case, guys. This is the use case, or else write it into the CSV file. Okay, simply you need to read the required attributes and then write it into a CSV file. That is your task. So how to read the final data frame? I need okay, and then sorry. So I want to have a structure like test underscore ID, comma, machine underscore ID, okay, comma, machine underscore model. Okay, similarly I need element ID tests. Okay, element ID and tests. So these tests are space delimited string. Okay, so that means from here to here you need to store it in the tests column. Okay, so that is how you need to generate your data frame and then write it into the CSV file. Okay, so how you will write the data frame into the CSV file is very simple, guys. Data frame dot write dot format. Okay, write dot format CSV. Okay, dot option header true, dot save, and your path gs colon slash slash. Okay, file path or else directory path, output directory path. That's it. Okay, this is how you will write your data to a CSV file. So you need to perform this task, guys. So one is using RDDs and data frames combination, right? I'm giving this task. So you need to read this text file and then do the processing logic and prepare your data and transform it into a structured data frame format and then write it into a CSV file. This is the complete end-to-end use case. Okay, so you can perform this task. I think we have discussed all the transformations that are required for this task. Okay, so you just need to put your brain to understand and get it into a materialized format. Okay, so that's okay. So you want me to upload to this file into a Git format, so I'll try to do that. Git. Okay, so where is this file upload option? I forgot. Okay, actions. Should be getting some add file button, right? Okay, so I'll upload this file to Git, guys. Okay, so you can get it from there, and let me see this file upload. I should be having the file upload option, right? That's the problem.
Account got signed out. I think you need to sign in.
Okay, so here I'm just trying to add the file. Upload files, browse. I'm just trying to upload this particular text file, guys. Okay, so that is the task that you need to perform. So try to come with a solution by tomorrow. Okay, so that in tomorrow's session we will go a little bit deeper to data frame based transformations. Okay, so how we do the transformations on data frames, how we write SQL queries on top of the data frames, everything we will try to understand in tomorrow's session. And then we will try to see the Spark configurations also in tomorrow's session, how to create our Spark session with all the configurations. Okay, so all those things we will see, how to write the data frame data to BigQuery table directly. All these things we will see in tomorrow's session. Okay, so tomorrow's session, don't miss out, guys. So it's very critical. We'll discuss a lot of real-time use cases tomorrow, and we will try to close the Spark things also tomorrow. Okay, so that's all I have for today. Thank you so much for joining once again tomorrow. Yeah.